This is how you're going to set up and conduct your graphs for the orbital velocity graphs. Please notice you are making two graphs. One of your graph is going to be about distance from the sun and orbital velocity. The other will be about planetary diameter and orbital velocity. Okay? Students often have competing hypotheses about what is responsible for the speed of a planet as it goes around the sun. You are going to use these graphs to determine whether distance from the sun or planetary diameter is responsible for a planet's orbital velocity. So after you have made these two graphs, it should become clear which of these attributes of a planet makes it go around the sun at its given speed. You are going to get this information using the chart on the back of your, well, it's not really notes, on the back of your questions. The y-axis for both of your graphs, because this is what we're really interested in, it's like our dependent variable, what's responsible for causing it, is the mean orbital velocity. Notice that I marked it here on my example with a y for y-axis. It's highlighted in pink. On graph 1, our x-axis is going to be mean distance from the sun, so that's a possible independent variable for this question that we're asking. Here it is, mean distance from the sun. I marked it x1 and I highlighted in green. Our graph 2, the x-axis is going to be planetary diameter, and I marked it, it's right at the top, I marked it x2 and I highlighted it in yellow. I wanted you to see where you're going to be finding this data. In order to set up your graph, for graph 1, orbital velocity and distance from the sun, on our x-axis we will count by ones, meaning every line is worth 1 AU, astronomical unit. That's a measure of distance in the solar system. It's so big that miles are useless. Our maximum distance is 30 AU. That's where Neptune is. All right, so we only need to get to 30. It fits on the page if we count by ones. Notice that I labeled my x-axis down here. Our y-axis, here we're going to count by twos. Our maximum orbital velocity is slightly less than 50 kilometers per second. So if every line is worth 2, 2, 4, 6, 8, 10, then we can easily fit it onto our y-axis without being microscopic. Notice again, I labeled my y-axis. You got to have labels. I'm showing you what to do. No labels, less points. Okay, here's an up close of how I labeled my x-axis. Every line is worth 1. I chose to label the 5s, 5, 10, 15, 20, 25, 30. You can label it however is convenient to you. Personally, I'm too lazy to label every number, but do what works for you. Here is an up close of my y-axis. I counted by twos, remember 2, 4, 6, 8, 10, all the way up to 50. Nice and neat, organized, I have labels. This is correctly set up. When you go to graph your points, you will graph each planet's velocity and distance as the point. Please label it with the planet's name so you know what planet you're looking at. This is the important part. You will have to estimate the location of some of the points, especially starting with Mercury and Venus. Okay, you can see that I've made some little lines on here to show that Mercury is at 0.39 AUs, Venus is at 0.72 AUs. You don't have to make these lines. I just want you to see how I'm estimating where they fall in between the lines of 0 and 1. Here is where I've placed my points for Mercury and Venus. Mercury falls approximately right on this line, but see how it's only just a little past the 0 line. Venus is closer to the 1 line. I had to estimate Venus's position on the y-axis as well as the x. That's why Venus is kind of floating in space there. Then you're going to connect the points from left to right with a line. Do not let your points go back and forth here and there. It doesn't happen like that. It has to be from left to right. You can see I've already connected Mercury and Venus here. I'm not going to do the rest. That's up to you. For graph number 2, planetary diameter and orbital velocity. Our x-axis, again, we will be counting this time by 5,000s. Don't let this boggle your mind. Pretend you're counting by 5s. Our maximum diameter is just a little bit less than 150,000 kilometers. So here's what I've done. 5,000, 10,000, 15,000, 20,000, and I marked on my fifth line 25,000. So you can see I've counted up by 5,000s up to 150,000. I also put a nice label on my x-axis. Your y-axis is going to be just the same as it was before. Exactly the same. We're counting the same thing on the y. That's our orbital velocity. Okay? Please put labels on there. When you go to graph your points, you're going to graph each planet's velocity and diameter as a point, just like you did before. The key here is that you must put on the name, and the planets are not going to show up in order on this graph. It's a little bit disconcerting. So for example, I've started here with Mercury. Fine, Mercury's first, big deal. Here's Venus, that's next in order, but notice I kind of slid Mars in here. Mars has a larger diameter than Mercury, a smaller diameter than Venus, so Mars is falling in between Mercury and Venus. A little bit unusual, so you just have to accept it. You're going to connect your points from left to right, not in the order of the planets, please. So see here, I went from Mercury to Mars because it's next in size, and then on to Venus. It's okay for them to not be in order. Your line cannot go back and forth. It goes only left to right. Once you have put in all the lines, all the dots, connected them with lines, you have two nice graphs. You will answer the questions on the front of the page.